Hey everyone, welcome back to our channel, where we explore the wonders of space and beyond. Today, we're diving into a topic that's straight out of science fiction, but grounded in some pretty intriguing science: warp drives and black holes. Let's get started. Warp drives have been a staple in sci-fi for decades. Whether it's Star Trek or any other space saga, the idea of zipping through space faster than light has always captured our imaginations. But let's be real, warp drives have a long history of not existing, at least not yet. The concept first appeared in John Campbell's novel Islands of Space, and since then, it's become almost a shorthand for super-fast space travel. But here's the million-dollar question: will warp drives ever exist? Right now, it's all theoretical, and physicists are still grappling with the concept. Recently, two researchers took a closer look at what might happen if a ship with a warp drive tried to dive into a black hole. And let me tell you, the results are pretty mind-blowing. So, what happens if you mix a warp drive with a black hole? Well, this is where things get really interesting. According to a paper published in Physics Letters B, researchers Remo Garatini and Kirill Zatramelov theorized that a warp drive could actually survive inside a Schwarzschild black hole. Now, for those who aren't black hole experts, a Schwarzschild black hole is a non-rotating, uncharged black hole, a sort of simple black hole, if you will. The idea is that if a warp-driven ship crosses the event horizon, basically the point of no return for most objects, it might still be able to survive if it's moving at a speed slower than light. The black hole's gravitational pull could even help reduce the amount of negative energy needed to keep the warp drive going. In theory, the ship could pass through the black hole and end up somewhere else without being crushed into oblivion. Pretty wild, right? What's a warp drive anyway? But wait, let's back up a bit. What exactly is a warp drive? In sci-fi, it's a way to travel faster than light by putting your spaceship inside a bubble that zips through space at incredible speeds. Theoretically, this could be possible by manipulating space-time around the ship. But here's the catch: creating a warp bubble would require an insane amount of energy. We're talking about more energy than we can currently generate, and it would involve exotic matter, which we haven't even discovered yet. Physicists like Miguel Alcubierre have been trying to figure out if a warp drive could actually work. He proposed a model back in 1994, but even he admitted there are still huge challenges. For one, the energy requirements are off the charts, and controlling such a drive might be next to impossible with our current understanding of physics. Black holes, the cosmic giants. Now, back to black holes. We've all heard about these cosmic giants, regions of space where gravity is so strong that nothing, not even light, can escape. The ones we're most familiar with are either stellar mass black holes, formed when massive stars collapse, or supermassive black holes that sit at the centers of galaxies, like our very own Milky Way. In this study, the researchers focused on Schwarzschild black holes, which are non-rotating and don't have any electric charge. These black holes are perfect for theoretical studies because they're simple and straightforward, making them ideal for mathematical models. What happens when a warp drive meets a black hole? So, what did Garatini and Zatramelov find when they combined the equations for black holes and warp drives? They discovered that it might be possible to embed a warp drive within the outer region of a black hole. The black hole's gravity would affect the energy needed to sustain the warp bubble, potentially reducing the amount of negative energy required. And here's where it gets even more fascinating. If the warp bubble is moving slower than the speed of light, it could theoretically erase the event horizon of the black hole. This could lead to some pretty crazy scenarios, like converting virtual particles into real ones, which might even allow us to create mini warp drives in a lab one day. The big takeaway. So, what's the big takeaway from all of this? Well, while this research is mostly theoretical and we're still a long way from building real-life warp drives, it does open up some exciting possibilities. Maybe one day, we'll understand the quantum mechanics behind black holes and warp drives well enough to actually build them. And who knows? We might even be able to send signals or images from inside a black hole, something that's currently impossible. For now, though, warp drives remain a tantalizing idea that's still just out of reach. But as science continues to push the boundaries, who knows what the future holds? That's it for today's episode. If you enjoyed this deep dive into the world of warp drives and black holes, make sure to hit that like button and subscribe for more mind-bending space content. Until next time, keep looking up at the stars